Welcome to ClickMyProject.com. Now we discuss about the product contour model based hand gesture recognition using the kinetic sensor. Now we discuss the abstract for the process. In this paper we propose a new hand motion procedures for establishing a real gender gesture datasets, and patch position scheme is designed for color based semi-automatic labeling. This method is integrated into an vision-based hand gesture recognition framework for developing some more applications. We use the dataset images to achieve the more reliable and accurate tracking under unconstrained conditions. Moreover, the hand gesture contours models is proposed to simplify the gesture matching processes, which can reduce the computational complexity of the gesture matching, so that only we use the datasets images for the hand gesture recognitions. First of all, the hand gesture recognitions is based on the many gestures which represents the directions and the finger like the fingers. The already captured images is only the input for the process. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset and the color classification is carried out. In the color classification process, the skin color is extracted from the image. The main reason is to extract the skin color is to detect the hand region, and the training data is the training datasets in the images. Then the gesture database is used to train the data, and the contour learning is used to extract the exact the wrist region from the image and also the finger region from the image. Then the matching is carried out to classify the images from the test feature and the train feature. Now the test feature is classified with the train feature, and then the classification result will be in the text form. Either the classification, for example, either the classification is in the form of in the directions or indicating the numerical form. If the given input is 1, means the numerical output will becomes as an 1. To extract the feature from the image, the feature extraction module is carried out. In the feature extraction, the data of the image is carried from the image like an centroids, for example, like an length, width, like that, so that only we can extract the simple features from the image, and then the features are matched into an train feature. Now we discuss the initial running procedure for the process. Now open the MATLAB and you can see the main.m file in the current folder. Right click in that file and then select the option run. After running the file, you can select the datasets from the images. Now you select any one image from the datasets and then click the button open. Now the process is ongoing. Now you can see the several images in the window. At first, the input image is shown in the figure 1 with the title input image. After getting the input image from the data set, we can separate the channels from the image. At first, the input image is the RGB image, then the channel separation is carried out. The first image represents the red channel, and the second image is shown is the green channel, and the third image is shown the blue channel. Then segmenting the skin tone is carried out. According to the skin tone, the image is binarized into an zeros and ones. Then we have to segment the wrist region only from the image. After segmenting the wrist region, we have to binarize the wrist region as an zeros and ones. The ones area represent the white region and the zeros area represent the black area. Then the edge detection is carried out. In the edge detection, the boundary of the region of interest only is shown. Then the contour detection is carried out. In the contour detection, we have to apply the contour for the image. In the contour detection, the green color area represents the contour area. Then in the figure 10, we have to input for the clusterings. In the clustering, we have getting the segmented image. The segmented image is shown in the figure level and the bounding box is carried out for the respected wrist region. Then the finger points are matching using the centroid terms. Now the accuracy of the existing as well as the proposed is shown in the figure 15. The recognized action is 1 is shown in the command window, as well as the accuracy is represented as an correct rate and the error rate is also represented as an error rate. Sensitivity and specificity are also is displayed in the command window.